Hi everybody, today we'll be looking at some simple examples out of the textbook with index ORs. So to start, let's look at these first two cases. If we have 3 to the 6 times 3 to the 4, we'll use the first index OR, which says if we multiply two indices with the same base, you add the index. So we'll have, put draw on, let's blow this up to full page. That will equal 3 to the, my pen's too thick. Could have thin a pen. Let's try again. 3 to the 6 plus 4, which equals 3 to the 10. You have the same base, add the indices. Oh, and you're multiplying. If you have the same base and you're dividing, subtract the indices. That equals 7 to the 9 take 5 is equal to 7 to the power of 4. So same base and multiplying, add the indices. Keep the base the same. Same base and dividing, subtract the indices. This can also look like this. Okay, so let's do some harder problems. Oh, this one isn't harder. This is just x to the 4 plus 5, which is x to the power of 9. And this one, we can regroup these. That'll be x to the 3 times x squared times y to the 4 times y to the 1. Because we're multiplying here, there's an implicit multiplication here and an implicit multiplication there. And when you're multiplying, order is not important, so we can rearrange them. Once we've rearranged them, that becomes x to the 3 plus 2, y to the 4 plus 1, which is x to the 5, y to the 5. In this case, we can multiply the coefficients together and multiply variables. So that will give us 6m to the 4 plus 5, which is 6m to the 9. Working with the first two laws is nice and easy. Oh, let's do some work with the second law now. So x to the 10, not take x to the 2, that's not right. Then take 2, which is x to the 8. And in this one, we can take out the coefficients first. 8 on 12 times by a to the 6 on a squared times by b to the 3 on b to the 2, which is, what's that, 2 on 3? Divide the numerator and denominator by 4 times by a to the 6 take 2 times by b to the 3 take 1. Oops, 3 take 2. That's 2/3 a to the 4 b. Nice and easy. Let's look at the third one. We have to use BIMDAS here, so multiplication and division have the same priority. We must go from the left, so we'll do this part first. X to the 2 plus 3 divided by x to the 4, which is x to the 5 divided by x to the 4, which is x to the 5 take 4, which is just x to the 1 or x. Next one, well, we're going to have the 2 times 8 on the top, the a squared times a cubed, the b times the b cubed, the 4 on the bottom, a to the 4b squared. When you have fractions, there's an implicit bracket here and an implicit bracket here. So we'll finish off the top and bottom before we simplify. So that will be 16 a to the 2 plus 3 times b to the 1 plus 3 all over 4 a to the 4 b squared. But we do a little bit more space here. Let's put a bit more space in. So it'll be equal to 16 a to the 5 b to the 4 on 4 a to the 4 b squared. Probably still need some more space. Which is equal to 16 on 4 is 4, a5 take 4, b4 take 2 is 4ab squared. Hopefully I haven't made any stupid mistakes. I'm pretty prone to them with these problems, I'm afraid. Equals now. The third index law says if you've got a bracket outside of a term, apply it to everything inside the term and multiply. So in this case, it would be x to the 5. Oops, I just don't need that. Times 4, which would be x to the 20. So if we said a to the m raised to the power n equals a to the m times n. Now we do have to be careful with these cases of what this squared term here actually applies to. So it doesn't apply to the 3, it just applies to what's immediately before it. We write the 3 as before, 3y 5 times 2, which equals 3y to the power of 10. The 0 rule, anything raised to the power of 0 is equal to 1. So negative 3 raised to the power of 0 is equal to 1. You have to be careful here. This 0 applies to the term inside the bracket. So it will be negative times 1, which is just negative 1. You can kind of think about it as being negative 1 times 5x to the power of 0. And this one, let's see, this would be 2 times 1 take 1. Y to the 0 becomes 1. 2 times 1 is 1. All of this to the power of 0 becomes 1. So 2 take 1, which is 1. Right, let's do some combination stuff. So this would be x to the power of 6 times by x to the power of 15. Add them together, x to the power of 21. M to the power of 12, multiply them together, divided by m to the power of 7, which is simply m to the power of 5. Multiply the coefficients together, we'll get 12. Multiply the variables together, we'll get x to the power of 5, divided by 6, x to the power of 5. 12 on 6 is 2, x to the 5 on x to the 5 is 1. That's simply going to be 2. Now here we have to be a bit careful. That power of 3 applies to both the 5 and the b. So this will be 5 to the power of 3, b to the power of 3, which some books will simplify to 125. b to the power of 3, because 5 times 5 times 5 is 125. Again, we have to be careful. Negative 2 to the power of 4, x to the 12, y to the 4. So 2 times 2 is 4, times 2 is 8, times 2 is 16. All the negatives will cancel out. Again, we have to be careful. The power of 5 does not apply to the 4 because it's outside the bracket. We write that down. 2 times 5 is 10. 3 times 5 is 15. Now the fifth law simply says if we have a on b raised to the power of m, it becomes a to the power of m on b to the power of m. So in this case, it would be 6 to the power of 3 on b to the power of 3. Again, in this case, we have to be careful of what the 4 applies to. We have to make sure it applies to everything inside the bracket. So negative 2 to the power of 4, a to the power of 8, 3 to the power of 4, b to the power of 4, c to the power of 12. And there's no real simplification there. 4, 2, 4, 8, 16. 16 on 3 to the power of 4, 3, 9, 27, 81. No, that's not going to simplify. So what did I say? I've forgotten now. 2, 4, 6, 2, 4, 8, 16. 16, a to the 4 on 81, B4, C12. C. Let's see what happens here. Oh, this is a little bit complicated. We might have to go down a bit further. Let's see. X6, x to the power of 6, y to the power of 9, on c to the power of 3, times by x to the power of 4, c to the power of 4 on y to the power of 4. We can do a little bit of cancelling here. Might get a smaller pen. This y to the power of 4 will cancel off with that. That 3 will cancel that down to 1. And we'll end up with x to the 10, y to the 5, c on, well, that's it, I think. Because the y cancelled out. Better be a little bit careful about how I draw this. Nearly made a mistake with it. Okay. So, as you can see, there's a fair few little tricks, but if you understand how each law works, it's not too hard. I'll try and put a red line around each of these. Fifth law. Can I explain the fourth law anywhere? Maybe I should write it down. A, B to the power of m equals a to the power of m, b to the power of m. So there's the fourth law. Then we get the third law, which is just this. And then we get the third law. And the first two laws I think I did up here somewhere. Here's one. First law and second law. Most of the time you have to remember them because they're on a formula sheet, but they're good to remember anyway because it helps you with your computational speed. I hope that was helpful and I'll see you soon.